Have you ever tried to analyze what forms the circuit of your smartphone or your laptop? It is a semiconductor that is used in every electronic device. Let's explore their working. Between the extremes of good conductors and bad conductors, we have an important group called the semiconductors. Consider a substance like silicon. At room temperature, only a few of its valence electrons are able to break free from their bonds. Due to this, silicon contains a small number of free electrons. On applying a potential difference across the ends of a silicon rod, the small number of free electrons available start drifting in a particular direction. They constitute a small amount of current which can be detected by a sensitive current meter. Such substances which contain a small number of free electrons, thereby allowing a small amount of current to pass through them, are called semiconductors. This small amount of current does not have any practical application. However, on adding certain impurities like arsenic to this substance, the number of free electrons increases to about 10 to the power 22 electrons per meter cube. In this way, the conductivity of a semiconductor can be increased. This process of adding impurities to a semiconductor with the purpose of increasing its conductivity is called doping. The conductivity of a semiconductor can also be increased by increasing its temperature. Besides silicon, germanium is another example of a semiconductor which is widely used in transistors. We have seen that the presence of a large number of free electrons makes a substance a good conductor, while the presence of a small number of free electrons in some substances allows only limited conduction of current in them. These substances are called semiconductors. The absence of free electrons in a material makes it a bad conductor. So, depending on the amount of free electrons in a substance, we can classify them into good conductors, semiconductors, and bad conductors.